All right, so I have 4 scenarios that I can think of. Okay? Story mode of a regression is you are provided with 2 points, and you have to find a third point using symmetry. At the very top of this, I'll write down regressions. Okay, just make sure you have that. This is still regressions where you have to make up your own points. The best way to solve this type is to sketch it first, and remember that the third point is across the starting point. That is your golden ticket. Okay. So, and in each of these cases, okay, let me just fast forward here to page 52 real quick. Each of these cases, you have, so let's say you have a scenario where the ball is kicked and reaches a maximum height of 17 feet after 1.25 seconds. This point, I hope you would recognize, is the vertex, which is very important to us. Okay. So x-axis will usually be time, and the y-axis will be height. So we know immediately that this is the vertex. Okay, that is the vertex right there, and we label it. And sometimes you have to assume things. If you kick the ball and it doesn't tell you you're standing on anything, then you're assuming we're on the ground, right? Like if we're assuming we're on the ground. So this would be a 0, 0 starting point. So this is your start. You get to the vertex, and at the vertex, I would like you to always imagine, or actually draw it out. You know that the vertex kind of tells you what the parabola cuts it in half, right? It tells you, like, if it took you 1.25 seconds to get here, right? It'll take you another 1.25 seconds to get to the other side of where you started. So in this case, this point right here will just be 2 times what you had originally. 2.5, 17. And this is your third point. That's the one that you had to do a little bit of work and use the symmetry of the parabola to figure it out. So essentially, I would like you to always set up an x and a y table and just put these points down. 0, 0, 1.25, 17. And then it's going to be 2.50 back to 0. So you can tell that these 2 points are opposite each other, because you start at 0, at a height of 0, you come back to that height. Okay? That's why we can just multiply the vertex, the x value of the vertex, by 2 to get that. So this is your start, this is the vertex, and this is your end point. This is the third point. Okay? Yeah. Oh, yes. Thank you. I got this one wrong, guys. This isn't 17. This is what? 0. Calm down. Take a break. Okay. You're good? Thank you, Isaiah, for bringing it up. Jamie and Tia, were you laughing because I got it wrong? Different story? Okay. Not this story, a different story. Okay, let's go over to this one. An object is thrown from a height of 8 meters, right? Reaches a maximum height of 13 meters at a distance of 3.5. That is the vertex. This one right here is the vertex. But now we're starting off the ground, okay? So we know this one. Let's label this one. The distance is your side movement, that's 3.5. And the y value, which is the height, is 13. You got that. What point do we know here? What would this be labeled as? 0, 8, right? When you haven't traveled horizontally one bit, you're at 8. Okay, so where's that third point going to be now? Where am I going to focus on? I will focus on, right? I'm going to use a ruler, and I know that I will come back to that point, right, on its way down. So what is this? The height will be, if it's 8 when you start, guess what? It's going to be 8 again here. Earlier we started at a height of 0. We came back to the height of 0, right? So this will be 8, and the x value will be 3.5 times 2. It's going to take another 3.5 to get to here, so that's 7. 7, 8. So now you're good to go. That's your third point. That one is worth highlighting, right? So x, so in this case, you know what? I'm going to go distance and height instead of x and y. We don't really care as long as you have the points. 0, 8 is the first one. 3.5, 13 is the second. And 7, 8 is the third one. And so I will highlight the 8s because you're like, okay, I start at a height of 8, I come back to 8. So that's, I'm using symmetry around those points there. So you're good. So this is where you use the vertex to figure out, it's almost like you're folding this over to find that other point that's across where you start. Okay? So these are the scenarios where you know the starting point, you know the vertex, you just have to find another one. This same idea, we're going to use it a little differently. This will be the scenario where the vertex is not provided. No vertex is provided. This is rare, but it has happened. Okay? So an object is thrown upwards, reaches a max height of 40. Let's underline that, max height of 40, and lands and remains airborne for 8 seconds. This is part of the vertex. We know that the maximum height is 40. We just don't know the x value of that. Okay? So we're going to go over here and just say this is something 40. And we know we're starting on the ground because it says the ball is kicked from the ground, right? Or an object is thrown upwards at least. We're not told off of a certain height. So we're assuming it's the ground. And it says it remains airborne for 8 seconds. Okay? So that's basically saying when time is 8, it goes back and hits the ground. So we know that this is 8-0. Can we use symmetry to figure out what this is? Yes. Because I know that these are at the same height. Right? So I can just split this in half to get this value here. I'm going to use a different color for this one. I'm going to divide it by 2 and get the 440 in there. So again, you have to read carefully. Will there always be a story? Will there always be a story where you have to find the third point? No. Sometimes the story will give you all 3 points. But if you're stuck, that's when you apply this knowledge here. Okay? So let's fill this in. This would be time and height. This would be 0, 0, 40, sorry, 440, and 80. And you enter that into your calculator, and away you go. The last one. It's kind of a weird scenario here, where the parabola is pointing up. It says a skier goes down a 30-foot ramp That means that we are at 30 feet at the very beginning. Okay, 30-foot ramp goes right there. The lowest height is 12 feet, and it reaches the initial height at a distance of 50 feet from where you started. So what we know about this one right here, let's make an arrow pointing to it. We know that the lowest height is 12. We just don't know what this x value is. Okay? So, we are told, I'm going to use a red pen here. We're told that to get to this place, which is the same height as our initial height, will take 50 feet. So 50, 30. Which means if it's 50 all across here, from here to here, it'll be halfway at the lowest point. So we just take this and we divide it by 2, that's 25. Okay? It's 25 right there. So here again, distance and height, it's 0, 30, 25, 12, 50, 30, and away you go. You found your 3 points. That's all you need to do a regression for a quadratic. So for today's examples, I'm only going to focus on coming up with our equations. I'm not going to dive in deep into all these other questions I could possibly ask. I'm just going to focus like, hey, can you find the 3 points and can you come up with an equation? So let's go to page 53. Maybe you'll recognize this question. It's actually from grade 11. But maybe you were sleeping. So now you get to see it again. 53. I'm actually curious. Okay, I'm going to do my work here. You do your work here. You try. Come up with the 3 points and come up with an equation if you can. Okay? Leave this for me. This is for you. But you have to try. You can't just be like, I don't know how to do this. Come up with something. Come up with 3 points that you think should be on there. Here. Let's see how you did. So we're recycling a beverage container, throws the container up from a height of 1.75, estimates that it reaches a maximum height of 2.8 meters after 0.75 seconds. That is your vertex right there. The container lands on the rim of the recycling bin. The bin is 0.65 meters tall. So let's see how we do this. Just a sketch. So it's time and height. So we're not on the ground. We're at 1.75 right here. And then we go up. And then this thing lands on the rim. Okay? And I did give you a bit too much information, so I'm wondering if that distracted you. But we know that this is 1.75. Right? At time 0, you're at that height. We know the vertex. The vertex is, you got to watch out, don't mix them up. Time goes first. 0.75, 2.8. And now what you need to do every time you do these is you want to focus on the point that's across. This is the one you want to focus on. Right? And what is that point? What's the height going to be at that point? 1.75. Same as your initial. And what is the x value going to be? 2 times 0.75. So that's 1.5. Okay? Mrs. Grayson, what about the 0.65? That one is right here, right? But we don't know, we cannot use symmetry to figure out what the time is there. So if you want to label this, you can say question mark 0.65. But I can't use it as is. Can we put down useless underneath it? I don't know. TMI, too much information. So basically, in that whole mess there, if you could highlight this, that is the point you want to be using in this case. Because remember, I gave you a starting point. I gave you a vertex. Use it to come up with the point across from where you started. So I will figure out, I will say time and height goes like this, 0, 1.75. I would caution against just doing that without making your table. Okay, this goes into L1, this goes into L2. Let's go ahead and type that in. Stat, calc, clear everything that's in L1 and L2, 0.75, 1.5. Then it's 1.75, 2.8, 1.75. I'm doing a regression. So I'm going to go to y equals. I'm going to turn on plot 1. I'm going to clear my y1, whatever I have in there. I'm going to clear that. You may use zoom stat at this point. 9, zoom stat. It gives you the 3 points here. So let's go ahead and do the regression itself. How do we know this is a quadratic? You just have to kind of figure it out based on the context. Okay? That if you throw something in the air, it's going to follow a parabolic kind of motion. Okay, so stat, calc, quadratic regression, 1, 2, alpha trace, boom, put it in there. Let's write down the equation here real quick. I'm going to break the rules and not have keystrokes here because it's too tight here. But this is the equation that I'm after. Everything that follows is going to be based on that equation. Let's hit graph. And it works pretty good. However, this is a word problem, so I want to see the x-axis. So window, I'm going to change my y-min slightly. Maybe I'm going to go -1 or -0.5 or something small because look at the y max, it's 3, right? There you go. So I see my x-axis. I'm going to increase my x max to 3, let's say. And there you go. Now you have the entire path and you can predict how long is it going to take for this thing to hit the rim of the garbage. Right, like the side of the garbage container. So let's go ahead and do that. It says here, this one doesn't hit the ground, guys. This one does not hit the ground. How long does it take for the beverage container to reach the rim of the recycling bin? Recycling can. Can is 0.65 meters tall. So we have to figure out when does it land, when does it get to this point. So it's basically saying what time, how long will it take to get to 0.65. What do we use to figure that out? y2 is equal to 0.65. Second, trace, intersect. So let's graph that thing. Y equals 0.65, hit graph. And this is when it's going to happen, right here at that intersection. So we're going to go second, trace, 5.
Ms. Hinter Janice, please contact the office. Ms. Hinter Janice, contact the office for phone call.
Maybe it's a good habit to put that point down in case you want to graph it. Okay? And for your notes, if you go back, I'm going to do this. I'm going to say that this is my 0.65 line, right? And it stops there. Some of you, when you graphed your cubic function, it says that the slide is only, that cubic function is only valid up until 30 meters, right? So you were supposed to stop it at 30 meters. You have to actually find that point. I did. So it takes 1.82 seconds to get there. Okay. All right. I have some work for you to try. I'm going to say pages 59 to 60. Oops. Sorry. My camera work is not good today. And 67, 67 to 68. That is just coincidence. But I made your day too, right? Okay, that's what you're going to do for the rest of today. I will say this. Focus on determining the equation. I don't want you to spend too much time on graphing. Okay, guys, if it's a sketch graph, anything like that, make sure you listen to this part. Just the equation, Jet, just 1 second. Just the equation. Just the equation. I know Lydia was talking to you, so maybe I should have said Lydia. Just the equation. That's what I want you to focus on. Find the 3 points, come up with your equation. And I'll tell you right away that there's at least one where they give you all 3 points. You just have to think. You just have to think hard on that one. I'm going to pause here.